data scientist. He has deployed several years of experience to solve real-time problems and issues in the different geoscience fields. He has a bachelor's degree in applied geophysics from the Federal University of Technology, Akure, and he also has a master's degree in exploration geophysics from the University of Lagos, Nigeria. He's passionate about the development of geoscience as a field, especially solid mineral sector here in Nigeria. He's actively involved in humanitarian activities like helping the less privileged in the society. We present to you Mr. Olakunle Obasoro. You're welcome.
Can everyone hear me?
Yes.
Can you hear me clearly?
Yes, we can hear you.
Thank you, Iyanu, for the introduction. My name is Kunle, and thank you, Flushgate Technologies, for this opportunity to discuss in this GeoPython week, a wonderful conference. I've been following online also. As Yanni earlier introduced me, I have a background in geophysics, and also I have a background in geophysics. Sorry, my child is, because I'm the only one at home presently, so she's trying to interrupt me, but no problem. I will take care, no problem. Just go and play with your tab. Yeah. So I have a background in geophysics. I have also a master's. I took interest in Python probably 3 years ago when I saw that the open source world was the way to go, and the opportunity for everybody to learn and contribute. This week I'll be speaking on geopandas. What is geopandas? It's actually a Python-based package that allow. Let me work. I'm working. I'm on a conference. I'm gonna work with your time. Now it's a Python. It's a Python package that allows you to work with geophysical data, geological data. It allows you to manipulate with your long lat. Excuse me. Let me attend to my So apologies for the breaking transmission. Yeah. So Geopandas allows you to manipulate basically your location, long lat, and what's the importance of that in geophysical data acquisition or geological. Whether you are looking for a mineral, you are exploring for oil and gas, or whether you are into groundwater exploration, everything is geolocated. It's at its location, or you could geoloc at a location. Therefore, there could be a partial spread of that resources, whether it be oil, whether it be groundwater, whether it be other minerals, because you can't find them everywhere. So the moment you have the longitude and the latitude, of a specific place, it allows you to, to pinpoint exactly. You could reference that point, and you could work with that data. Just especially, you could reference it, connecting dots and saying, okay, and building maps, volumes, and the likes. Now, one of the interesting thing about pandas is that is a package, and is being built into the geospatial and geophysical analysis of data, of data analysis. So basically, what we do when you have when you receive, you collect data, you could plot it, you could do a lot of things. You could do differences between your location. There are a lot of I call it application that geopandas comes with. Now, because of most of the times we work with shape files. I know for those who work on, if your background is not in ArcGIS, or you are using other software like QGIS, those people who work around that area mostly, they work with shape files. But now, I the world of geoscience and the world of shapefiles is being integrated, because geopandas allows us for such manipulations to work with it. You could see, and your plot could be in a point or polygon. Now, what do you mean by a point? If I take a location where I'm seated now, there's an exact longitude and latitude for it. Now, if I we can also create a polygon around wherever you are. If you are working on probably if you are used to working on Google Earth, you could create a polygon map, and each point, so it's a connect, and polygon is a connection of what point within that axis. So you are connecting probably 4 or 5 points together, and you're able to say, okay, this is a polygon, and you could see how it looks like in a map. But then the like I said, Geopandas it's a package, but it's still getting a lot. There's still contribution year in, year out, and so you see a lot of people working on things, and before you know it, it's going to become a very robust package in the, like most of other open source geoscience packages in Python. They are still, I still say there are some of them are still in their infancy stage, and in the next few couple of years they will be so robust that they'll do a lot of things that will amaze the world of science. So, not to bore you with a lot of stories, the data I'll be using actually is the Volvo data. It does the training data, because just to show you, to spur our interest on what your pandas could do, how you could go about it. The reason is that the USGS has a lot of shape files. You could download and keep working. Just do a simple plot, look at it. Then you could. The USGS is a reporter of data. Like for us in this part of the world, we are also trying to start working and gathering data that will actually become a plus that people can use locally and to solve problems. So to not bore you, Now I'll just go to my slide. I guess everybody can see it. Now geopandas is lying on other packages. One of them is NumPy and pandas. And these two so what is NumPy? NumPy is numerical uh, Python. So it allows you to do a lot of 1D, 2D array, manipulation of your data. And these libraries, basically, that's the library GeoPandas is sitting on. They are sitting on this tool for it to carry out the processes that you are doing now. So I will plot. I will run this. I'm working on Colab. I know some people are used to. If you look on my screen, probably you'll see I have Spider. I have maybe VS Code also open, and I use Jupyter Lab or Jupyter Notebook, depending on what I want to do and what I really want to achieve. Uh, if you want quality good plots, I think Spider does the rendering is much more good on Spider. Then you have to import do but if you work on Colab, because it's a Google open source lab notebook, it has a lot of background that it gives you, because it's on cloud. There's a lot of things you could run that is behind that gives you uh, quality rendering of your data. So I will run this. Uh, I'll run this. If you are I'll run it. Or basically, let me just put the runtime, and I can put if you're on. Okay, I'm running it. So on Colab is going to is importing my NumPy, importing pandas, is importing the other packages I added to it. You can see it's importing it. Now when it gets to that place, when you check if for example let me say I missed let me say I miss a point on my Colab. Let me say instead of importing mat.lib instead of mentioning pyplot and then pyplot dot, if I should run it now, there's going to be an error. Now on Colab, the moment you see that it says error, it says no module named man, so you could see that my module was not properly imported properly, so it's generating that error for me. So I have to go back, and you check your code, and that's one of those things about Jupyter Labs or Jupyter Notebooks. You can go back and look at the module not found error. You have to read it. That's where it allows you. And one thing is that you can see where it's the line is actually picking. Line 7 on my line says, and when you go and read the error, it says module not properly imported. So I have to go back to that place and say, okay, I think I missed something. I check it, I run it. Now, so it's probably run. Now because my data, it's what Collabs allows you is that if you want to bring in your data, you have to. It's based on Linux. Uh, the background, what is running behind is like is a Linux system. So you have to mount the data. So if you understand in Linux, it's you have to if you a little bit of Linux, you understand that you have to mount your data. You can mount something on if you are used to Linux. So that's the same system Colab is using. So that's okay. I want to import the data, but I don't have the package how to import it. So I have to run Google Colab's import drive, then drive.mount. So that mount allows me to import, it can host my data. So I'm going to run it. Now, It's going to bring out a Google account stuff. So this is what I'm going to do. I have to click this Google account. It's going to bring out if you have a Google account with this thing, it's going to open it up. So it allows you to copy, allow. When it allows, it gives you what? A code. You copy this code. I go now. If you see on my screen, you see the Colab is saying it's not. That means it's not running properly. Now, if you check, I have other collabs that I've opened. You see that it seems they are running in the background because I'm working on other. I'm writing some. Not this. So it allows me. So in this, enter your authentication code. I copy and paste and enter. So it's running. So I go to my line because I've mounted the data already. So I'll run this. I call it the well data because why? I'll explain why. So I'll run now. I've not seen this data before. So, but because I made correction to it, I'm going to edit something on this place, on this code, on my code now. I'm going to run this data, run this cell. Now it's giving me an error. It said only single character Unicode convert to PS got line 0. So I have to go to which place, which line. Okay. Let me run that cell. Now, so like I said, the moment I changed something and it didn't now because I loaded that data earlier and I found that I was having errors. So I needed to find out why. If I changed that separation in pandas, when you are importing a CSV file, that if you go to the documentation, that different modes your data could be stored. So sometimes as data scientists or you are into Python using for data analytics and you don't know how the format your data was stored. Now it's good you try, because I found I loaded it before it gave me error, it gave me an issue. I wandered around, I used comma, finally, I tried this and that's how the data. Now, in this world log, there are a lot of information, but for us, I'm not interested in all the wells, the density logs, the gamma ray logs, all the other logs and the little fascists that was stated. I'm interested in the x, the y, the longitude, the latitude, the latitude, and and the depth. That's my interest in this for using geopandas. And that's why we are using. So you could run a well dot shape is going to give the shape of the file. And it tells you that I have 29 columns and a million and 170.170511 what rows. That is a very, that would say, we say, looking at our industry, a large data, in its sense. So if I run that now, I want to know the columns so the one I run this dot columns now basically is just to explore the data. But I said earlier, I'm only interested in X and Y and Z. That's what I want to use for my for pandas and analysis, just to plot how it looks like. Now, if I plot it on Matplotlib, it's just going to give me the x. I have to put the x and y. But because in pandas, in geopandas, I want to plot it my longitude and my latitude. That's what I'm interested in. So the moment you run this cell, you see that all your data, your well logs and that they are stated there. You know, uh, if you weld your columns, if you, that was the columns that, but I'm not interested in the rest. So I get my well information. Well, if I run well.info, which you could type that, it's simple. You see whether you have floating values. So for my x and y logs, I can see they are floats. Okay, so that tells me that they have dot a point a value after the numbers were stated. So now what I usually love, people use, well, now people could use, instead of like this one, some people use dot na, but I love using dot null. I think I'm more comfortable dot null, you know, dot sum. Now, why am I running this? It gives me the number of missing values in my cell, in my data from all the columns. Now, so if I look at my well, all the well informations, they are complete. The depth also is complete. Now, I found out that in my location that close to 10,775 locations were missing. So now, if you look at, we had 1,100,000, over close to 1.8 million data set, and in that location, we only have like 10,775 missing points. Now, is a choice as a data, you who wants to work. Okay, is comparing the ratio, is it something negligible? For my analysis, is it going to compare to what I want to do? These are things you need to. As a person, I can't decide that for you. I can't decide that for it's your team that is going to make sure. Okay, I think we can. But then the reason is that you can't do. The danger is that if you say you want to use for location, you want to use an average system. You can't. Your well could be in one position and another then, and we have a missing well, and you want to use an average location you are not sure of. Then it's going to bring error into your plots already. So that's one you have to be careful, and it's okay. Then if you run bring in the number of, if you just want to, whatever I'm doing is just data, just to explore my data to see how it looks like, dot unique, your well look. Now this one tells you the type, the total types of the world numbers that were there. We have 159 that were numbered, specific, their names given, so you could see it, and you could run it. And then now if you run dot value dot count, it tells you the total number of, for each, for the total, the total numbers. You could see it, it gives you the numbers to the end for each particular well, for each, for in their uh in the, now this code, and this line of code, I actually saw it from a colleague of mine, Olakunle Obasoro. Well, it's the same thing I ran here, the value.count, but you actually use the numpy background, and it's this thing, and it's the same. So number of wells in the data, it gives you 98. If you remove this, if you run it, it does give you the length, giving you, but it's the same. That's why there's no one straight code, but how fast. The only thing I didn't do was I wanted to test the time it will take both codes to run, to see how efficient and if I run this dot value dot count and this other, and I didn't check the time, but it's something we could look, because the faster your code, the better for you. If your codes are slow, that means sometimes it leads to crash and you have to go back. Sometimes you find, so it's the same thing. I will have looked now. So let me just go back. There's this stuff I started playing with recently. It's the Google Earth engine. You could also install it, but for this lecture, I'm not going to install it running on the Google. But it's something you could work on. It's uh, if you don't want to work on Google Earth, as it were, let me say you don't want to work on, but you want to work on it on your system remotely without going to Google Earth. The Google Earth API is a fantastic tool. You can run it as in. I hope. Let me see. Let me open another. Let me see a tab. Okay, not this. Let me close this. I know this is what I'm working on.
Okay, so in this lecture, we're going to talk about the LU decomposition and how we can use it to do efficient computation.
So basically, I want to go back to what I'm doing. Okay, so that engine allows you to run Google Earth remotely on your lab. You don't need to say you're on Google. You can work on it remotely. You just need to install it on your from your bash and just pip kunda dot. I think for kunda. I think I wrote it down. Kunda install Genpy. Just fork it and it will be on your system, so you can work on Google Earth on your system. You don't need to have it like I have to go to Google Earth to go and see what I want to do. You can work on it. So, but this I was trying to work on Google Earth on Colab, but I it's installed, but I've not. You have to go through the same process of installing, authenticating it through GCP, your Google, your Gmail, and you have it installed. Now, okay, let me run it. Let me run it so you see that how. Let me just run it. Okay, it's going to ask me for engine authentication. Still running. I think it's slow. Let me check my network. Okay, I'm connected. Okay, now it has come up. What is it saying? Okay, let me run it. Okay, so an account has come up. He said I should authenticate it. So he's going to go back to my Gmail. So I click allow. All these are necessary for security. So that no. So I'm going to paste it here. I hit enter. It's going to authenticate. Mine says saved. I run this. Now I'm going to run this. So what I'm going to do is, because okay, I'm going to say maps equals to no. Let me see. I'm trying to. Let me see. Let me look at. Import EE. I think I failed to import something. Gempi. Wait, import. Okay, I need to. Let me see. Gempi. I need to say Gempi. Now let me find. Okay, let me run it. But as I said, I started using it recently. But basically, what you can do is you import the whole of the Google Earth itself into your into your system, and you can create your maps. You can look at your location. You can cycle those points, and you can overlay those. You can carry out those interactions with it. I think it was developed by Professor Liu. I've forgotten the university, but that's basically now geopandas. Now this is where we are going to. Now we've done exploratory data, looking at what we wanted to, the data we're giving. Now, because I wanted us to work with data we see daily as in our field. Maybe if you're into solid minerals like I am, for example, if you're carrying out a 2D resistivity survey over a structure. Now, at each point where your electrode is you are going to put your electrode. For example, you are doing you want to acquire data over a 1,000 kilometer, and you are using a multi-electrode channel. Now, each position, you have to take where your electrode is going to be inserted. You have to take reading, a GPS location, so that by you look at it, you can go back when you're interpreting your data. You can say this is the position you feel the structure is actually lying on, the location actually from the interpreter, and looking from your 2D resistivity data, and you can put the location, plotting it on using the software you've chosen. Now that will allow you to say this is the exact location, and when you want to go and test drill, you are not on a wrong location, because drilling itself is expensive. So if you miss where you are going to drill or you are going to core, then the client is going to lose money and your job is not successful, because the agenda is there a resource there, whether it be lead, zinc, whether it be gold, whether it be other minerals, even water. Now, the next thing is we're going to run Folium. And now Folium allows you, it works under hood with geopandas and other plotting tools like Matplotlib and the likes. So by the time we run this, because geopandas is not a part of the package that Colab comes with. you have to install it into it. So that's why we have this symbol, pip install geopandas, and by the time you run it, it's going to install. You see, it's collecting all the necessary resources needed, and if you go through it, it's good to it will tell you shapely. It's because collabs allow you to have this. It comes with it. You see pandas. Let me look at it. It says pandas, numpy. Or if those packages are not there, it's not going to run. If you don't have pandas and numpy, it's not going to run at all. So, and you have to go back and install them. So because those requirements must be satisfied. Now if you look at it, it says requirement satisfied. We have pandas. That must be satisfied because that's what allows your pandas to run. So because I don't want to bore with now the issue. Okay, I've done some. Okay, so I had, well, now we said import pandas as GPD. Now that becomes, instead of using pandas, geopandas in our listing, it's going to become GPD. Now this will, all those other codes I was just playing around, finding, understanding how they work on that hood. So let me see where. Okay, because some I just make sure that I left them in there so that we solve the problem. Now in this place, it's still the same. I've imported. I didn't follow the code sequentially like I was supposed to do. But what I did was I worked from the back, starting from the end of the code. I was just working back into but I want to go to where I started. Now, this is where it should be. GDP. That's the name I chose. Now, pandas, because it's a geodata. This is a geodata frame. I know I'm importing the data that I have, but because I'm only interested in, as I said earlier, I'm always interested in my X and Y and Z. That's all. That's what I have. So what I did was importing geodata frame, my point and everything. So if I run this code, so it's just like the same way you are importing CSV, pd.read CSV. The same thing you do, pd data frame, geodata frame. Now it's going to read it has read in my data. Now I say I want to know the columns. It's still the same way like a CSV file, but I'm not interested in all this other except my X, my Y, and my Z. The rest I don't need them. For those who are interested in plotting your well logs, that could be your interest. If you're interested in your density, gamma, and the likes, that is good because that's what your interest. But I am not interested in that. I want to see what geopandas can do for me, because even if you look at it, your interest will not be in the X and Y location, because it just gives you. So what I did was I went back. I want to drop columns that I do not need in my data set. Now, what because it's the same hood is running with pandas, it allows you to use drop columns. So you can drop columns. So what I did was I copied from this position because it's there. I copied from this place down to this place. I brought it to this place and ran the code. So I did that. I'm going to run this code. Now, it's telling me the code is okay. Now, what he has done is that I've dropped all the codes, but I have a problem. Now, if I press below, if I do .info, now it tells me, okay. Now it tells the GD, it gives me information that these columns have been dropped. But I have a challenge that though the columns have been dropped, I still have a non-value and a non-value within the scope. So that's within my data set. So what I need to do is to drop those non-value. I don't want them in my data set. So just bear with me now. So what I did, sorry, where am I? I need to know. Okay, so what I did, so just to, so if I should write JDF dot now I still have 1,775 missing values. We have close to 1.8 million data set, and I have a missing value. I don't need that missing value, because if I should plot it, I'm going to get errors. It's going to generate error, because if you should do that, it will tell you, if you run that code, it will tell you that there are non-values within your within your data set, and it's not going to run. So what I did is, the next line, I ran the same code and I said drop what? NA. So the moment I do run this, drop NA. So if we should check it, I should, okay. So if we should do this, dot, now it allows you, I need to check whether what I'm doing is right if I don't have missing values again. There's something, okay. Now, if you see that it tells me from the world, there's no missing depth, no missing data, logs, no missing data, your your location there is. So now I don't have a missing data. Now I ran geometry. There was no geometry column in the initial data that was given to us, but I created this column, and that's where I ran this geodata frame. Now, what did I do? It's a Python code. I called this geometry. I called that this point XY, and I named it that my XY should be, if you look at it, my XY should be my X log and my Y log. So since these codes are in series, if you look at it from so it's going to go to that column, and it is going to create another column for me, and it will name it geometry. This geometry. So this geometry column is a combination of my Y, my X, and my Y. Because when I want to plot in geopandas, it's going to plot based on I said earlier that is either a polygon or a geometry. No, a polygon or a point. Sorry. Now, since it's a point, it's just going to be one point. So each point has both X and Y information. Each point both has a longitude and a latitude what value for it. Now, but if the data was, if during the acquisition of the data, they created that they connected those points together, is going to form what you have polygons setting for them. So this is what, so simply with us, since we know we've dropped these values. Now, if you see at this point, I put a hash, hash. If you look at it, hash, hash, hash. Now, I don't want those codes to run. Now, the reason is that the data, if you look at the x and the x coordinates, I don't know the EPGS value for. I think the data was acquired around Norway and the North Sea. So why, in the process of working on this notebook, though I didn't do complete, I wanted to know which part, if I should plot it, but then I wanted to know which part we have this change in this EPSG values. For example, in Nigeria, if you are working, if you are working in Nigeria, you are if you are working around somewhere the southern part of Nigeria, you call it zone 31. Now, the moment you cross probably Lokoja, if anyone who is familiar with Nigerian terrain, or what we have the confluence down around the axis, you go to zone 32. Now, if you are someone who acquired data and you acquired your data and you didn't know, for example, you acquired it in somewhere in let me say up north, and you reside somewhere down south, and you didn't even do that correction, you've already introduced error into your analysis. So knowing that, so that's one of those things I wanted to go back and understanding the data, which is part of those things. I personally, now I know that when I plotted the data, which you see the plot itself, I knew that there were likelihood that they will have those differences in location. Zone 30, I don't know in the, I know but it's in Norway, but in Nigeria I know zone 31, zone 32. So if I acquire data in Lagos or somewhere down south or somewhere in Ogun State, Ondo State, Enugu, I know that I'm working around zone 31, and I will correct my data towards looking at that, making correction towards using that, having that in mind. But if I bring data from somewhere Kaduna and I don't do that correction and I say, oh, I forgot I zone 32, because I've actually seen that. I've worked on, it gave me different this. By the time I did the correction, I say, wow, and I have given a wrong location for drilling, and I have missed it. And these are things we need to look in. If you are going to, as geoscientists, geophysics work on the field. Yes, we acquire data, but we must know the location. So when I looked at this data again, I know there was something missing I don't have information about. It's different locations that the world data were actually acquired, and which I still want to read about it. If you see, I have tabs around open. I want to know which one, so that I can do a proper correction that this is. So if you look at my data, you see I was trying to CRS, so I'm not sure of the EPSG I gave. I actually ran it, I got an error. I wasn't supposed to get an error. That means it wasn't correct, because they have different EPSG values. So I want to know the right one. So I have to read, check Google and know the right one for this place. So now if you see after running this one, now if you see that I have, these are my well location and everything and the likes. Now I want to know my well count and everything, number of my location, everything is complete. I don't have any missing values, everything is okay. Now if I what it does for you is that it can allow you to plot. So if I put so it's running. Now the issue, I don't know why it's taking long. Let me check my internet connectivity. Okay, see how it's connected. Okay, it took me a while. Now this is the plot. This is how the wells looks like, the plot. Now if you see this, your coordinate. Now you see my longitude. Now that's why I said I need to do a correction that will finally. So you could see this is how you could see the plot of my well, the geospatial relation between the world, looking at a 2D plot of the world. So I can say that, like I said, I was explaining, I believe that if I do a proper, and if you notice that the walls within this area could be in a different what we call, as I used before, location. What I mean, like I was explaining, that zone 32 may be in a different zone, different from this. So if I don't do a proper correction of each of this around this axis, it may look, yes, you are doing if I'm to tell someone to go and drill, I know exactly, the person may miss the point by a fraction. And when you are drilling and you miss your point of target, it's going to cost your client money. I think I was discussing with a senior colleague, and we're working on inversion. He was trying to take me through, and he said when that same thing, they didn't do a correction where the well they wanted to drill was 4,000 meters, 4 kilometers. Let me say 4 kilometers from the troop location. If they had not done that zone 31, zone 32 correction, which a lot of times you could neglect, because you are a geophysicist, and oftentimes you say, oh, so surveyors, that's their. You need to understand what surveyors do also, because it will allow you to understand how you can carry out your geospatial analysis and properly understand how you are working on the field. Now I can see it, but then, like I said, it's something I'm still looking at. I want to understand the EPSG, and I know the right value, and I can carry out the right analysis for it. I don't know if anyone has any question, because I've been talking, and I would like to, let me check the chat box, the chat room. Hello.
Yeah, we can hear you so far.
Yeah, we can hear you. I don't have any questions for the time being.
No questions so far.
Any question?
For now, no.
Oh, so no.
Yes, Tola, we can hear you.
Yes, yes, we can hear you.
variable. I said that's the new variable. So because I have the data, I wanted to convert it to CRS. That's the new coordinate projection, the new projection. If I run this code, if actually that is, if I find that for Norway, North Sea, and I'll be able to change the projection. It's as simple as that. It's a one-liner code, and you change the projection. Now, sometimes, okay, I think some thoughts are coming in. Let me get into the mind. You acquire data in universal UTM. You can be in meters, it can be in degrees. Now, you want to convert. You can do that just using a one-liner code. You will in Python. And that's why I use this one. I wanted to convert it. So if I actually put this, I can't recall the exact the EP, but you can Google it. It's I know sometimes some of this word escapes your mind when you are, the CRS, the meaning of CRS is coordinate reference system. So I want the coordinate reference system. I need to get the actual words where within it exists. If I put the actual value, it allows for easy conversion of that stuff, of that your X and Y. Whether you've acquired it here, you want to change it, it's simple. So it's just one liner code. You can do that. Did I actually answer his question? If he has, hello, can you hear me? I have only one here. It's the same question. It's the same question. How can you convert latitude and longitude X, Y in spherical form using Python? X, Y from one projection to other. X and Y data from one projection. It's, it's, yeah. For example, now in geopandas, you can. I wish I could share another part. I have, like, you could work on GeoJSON. So these are packages that allows you to manipulate geolocated data, whether in your geoscat data or geological data. Now, PyGeo is still the same thing, but how robust it is in handling different, whether I don't know. I have not used it, but the ones I've used, there are a lot of packages coming up. People are bringing out packages every day. Models are being developed. So that's why I said in the next couple of years, some of these packages will be so robust, they'll be so integrated together that they'll be doing awesome work. That people, you don't need to have, you don't need to, let me use the word, if you're installing them, they come together. So that's the way I see it, the way the future will drive this agenda. I've not used PyGeo, but I believe that it's similar. But I'll take it down and I'll check it. But what I'm saying is that I believe they do the same thing. But in the nearest future, some of these modules or these packages will be integrated together that in open source, that people will do amazing work in solving problems in groundwater, mineral exploration, oil and gas, in in a minimal, depending on the way you want to look at it. Any other question? Okay. Okay. And okay. Let me look at. Is it this? Oh, Okay, I think now, like this was I was working with Lazio, and and now I got this data. This data was actually given to me for my master's. I wanted to work on seismic inversion, acoustic impedance in reservoir characterization. That was the idea. I needed to work on some other things. So uh, last year was a guy when I stumbled on Python packages and models. I saw there were other ones, Welly and the likes. But then I think last year was so robust to do it could handle some of difficult wells. I think some like difficult wells, the way they were, they were lumped together. So you will see importing of libraries. I imported the libraries. Now, I one thing I usually do is I don't like I usually like to make my code simpler. That okay, well one, well two, so that I can import them, follow the sequence. So if you look at it, you'll see an imported well one. Now well two, last year the three, it's they have the same under the hood is like pandas that is working. So working with three wells. I had five wells, but I just wanted to work with well 3, 4, and 5 because I felt they were the most they actually cut through the horizon for me. Yeah, the particular sand of interest across board. That of well one and well two, they picked the different sands. So, but I think well 3, 4, and 5 actually went through the same this thing. So this for iteming. So you have to check the documentation of Lazio, and you see how you could manipulate using your this. So these are basic uh, Python this thing for items in well one dot well. Now this is stated well one dot one print. Now this is formatted, him, and then a dictionary. He allows you to put a dictionary items and the items of value, items of mnemonic. So it gives you everything about that well. Now the information I need for that well. Now you see the dates missing, but now it tells me now this tells you the month that this was given, the province, all these were missing. These are information that were not in the well logs for me. So, but I was just interested in the well. I think I had the data for the location. So I had this well one. I needed the values and stated it. Now I needed the information in well two, all in all the wells. So in well one, I had density, gamma, neutron, resistivity, and this one we did in well one. For well two, this they had so much logs. You could see density, gamma, your sonic, your drift. Then well three, which was well five. So that was basically what was there in the world in the logs. Now, I the essence of this code is this particular code was to give me the values. All is just within the heading of the logs, just to see what it looks like. So if I check the log itself, the way they gave me, the same way it is. So Python Lazio could go into the and extract it the way if I'm to actually view it using maybe my notepad on Microsoft desktop. So the same thing now, because this I needed to convert the well data into a data frame. Now, without converting it to a data frame, I would not be able to view it the way that I was able to view it. It will generate errors. Now, if I go back, that is the same code. I ran well1.head. It said last file object has no attribute head. Lastio itself does not have the attribute. So I have to make sure that Lastio has read the file, but I must now find that that connection between Lastio, who is running under the hood of pandas, to help me to read this file. So if you actually read Lastio, you've read your way and say, well, when I run it, then I usually like to keep the errors, because sometimes you may think it allows you to know, okay, this is what is actually happening in what you are using, because you may think it's so when a last file object has no, so the last year itself does not have that, so I have to convert it. So that's why in this place it allows you that, well, I have to rename it .df. So it's I have to call that data frame, give it, connect it to the data frame. So the moment you do that, Lastio understands it. So if I now read well1.ed, you see, it's like, wow, I can see my well logs the way it is. Now you see that in this data I don't have my x, y, and my long lat, because it wasn't given to me, it wasn't included. So I did that. Now, well, I did the info, floating numbers. I wanted to check whether they were missing values. You see there were 251, 3. Okay, these were the missing values. The wells, everything was complete. Now, I was trying to do concatenate well 1, well 2, well 3 together. So it said cannot concatenate object of class. That's your only series and data depth. So as I said earlier, errors allows you to know what is actually happening. So if I want to concatenate, what should I do? If in trying to concatenate, I'm getting this, so what should I do? What's the solution to it? So we'll get to that place. So because I did well one dot column, it gave me the number of columns I had in that well, but I didn't want all this other. I needed just density, neutron. So I said, I want DF drop. I want you to drop all this other. I don't need it. I did that for the same thing. Well, too. I ran the same code, and I dropped the other stuff. I said drop all this other. I don't need them. I wanted to work with just density, gamma ray, neutron, resistivity. Since it was common to the tree logs, I did for well 3. I did the same thing. I dropped. So this was well. So as I said earlier, I wanted to concatenate them. Now, the reason why I could not concatenate it, he told me, if you look at this code, he said cannot concatenate object type this, only series array are valid. Now, if you see that my wells were in different, well, one had 5, close to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can't concatenate with another one who had like 20. It's going to give you, your data will be in a disorderly manner. So what I did was I made sure everything was simplified, and what I did next was to concatenate the. I'll just run through because of so I was able to concatenate the so I say well combo, well one data, this thing, I ran it, so I was able to concatenate these wells together. So reason was, I said earlier that they had varying. I was interested in well 1, 2, 3 because I felt, looking at them, they cut through the same this thing. They were passing through the same horizon, which was my interest, the same sand bodies, which was of interest to me. That I was going to run in fashion on. Number 2, I was interested in it because of depth. So these are things, you look at depth variation. I looked at the depth and I found out, okay, I could look at it. Now, by the time I did that, you could see this the combination. So by the time I did the well combo, I had 6, 1, 2, 3, 4, 5, with depth. I did the word.describe, which gives you the descriptive statistics. So you see 20% for, the way 20, basically the describe, the describe in pandas give you a descriptive statistics. So your descriptive statistics allows you to see how your mean, your standard deviation, how it's varying from, and what you need to correct from your look into your data and find which one. For example, if you're into machine learning, this gives you idea of the feature engineering, because it allows you to say, okay, I don't need this, I need that, I think this is out of place. But since we are not going deep into machine learning and the likes, but the descriptive statistics, you can see it's not just numbers, you have to look at it. Okay, I have, for example, my density of my mean in that place is 2.26. The mean, the standard deviation, that is how it's very, the mean value. Okay, what is the max? Is 2.2 this thing. So you have to look carefully. Okay, what does it really mean? In looking at my sand body, or looking at the whole logs, because you are giving the mean value for the whole logs density value for moving from the point of when they started acquiring the data to the point when they ended, and that's okay, the maximum value, the mean value, the mean, what does it mean? Okay, you have to, what does it represent geologically, what are those things, because it's not just numbers you are dealing with. You are dealing with expert knowledge now. Numbers are numbers, it doesn't mean anything now, but it's you that you begin to interpret based on geologic insight, geophysical insight, and say, okay, this is what this means. I have for my neutron value, this is what I'm getting. What does it really mean? So running the combo, because this is where now I ran this. Now, if you look at it, looking at this plot, if you see, it's both neutron and density. You know, I see something striking about this place. You know, I look at this other part. There's something also in the visualization. I guess people can see. I don't have, I wish I'd had a pen to those. Then, if you look at this, there's something around, this. That's why I was saying this well 4, well 5, and well 3, 4, and 5 were of interest to me, and I needed to look into it, and which I for me was more of yeah, there were a lot of information I needed to do, plotting my density and my neutron against each other, because I believe in for those who are expert, who are more knowledgeable than me in oil and gas, I guess when you run both logs together, there's where both of them they have to form this cone, this kick, and you could say, oh, there's likelihood, there's a gas, there's oil in this place. So for me, I wanted to say, okay, I need to look into what I'm seeing in this place, to basically give me an insight what I'm doing. So I would like to stop in this place, though there are few, the rest are just descriptive analysis. But then, for everyone who wants to go, you could look into it and look in how your data is speaking to you and of interest and what you could make of. I don't know if anyone has a question, and I will gladly, respond. Hello? I can drop my email. If anybody has anything, they can reach out to me. I can put that on the chat box. Is that fine? Hope the lectures weren't too boring, because I know I was talking too much.
I'm wondering, Kunle, I have a small question. Why did you concatenate your well
Can hear
logs?
you.
Why did you concatenate your well logs?
Okay, the reason why I concatenated the well logs was I wanted to put them in the same, let me say, the same container to actually plot them. If you look at it, if you look at my code.
Okay, so you're bringing all the values together regardless of depth.
Yes.
Okay.
So regardless of, I know they were in different, so I needed to bring them. So it's going to plot within, well, one is going to plot within itself. Well, two is going to plot within itself. Well, three is going to plot within itself. So it allows me to see it. Now, the reason is that I had done, because I know I was talking, I had done a group, I had grouped it. Now, the way of group by is, look, I want to group my data, this and that group. So if you
Yeah,
look
I
at my
see.
plot,
Yeah, to
I see.
aggregate.
So I'm working with, so it's working with a certain group of this thing. So I had to constrain it so that I'll see it. That's why, it allows you. That's the opportunity of open source. If you had this, you have to do this in a software. You have to pay, but then with few lines of code, you are good to go.
Yeah, interesting idea. Yeah, to aggregate all of one kind of value for these crosspots here. Thank you.
Yeah, pleasure. Yeah, I think I'm done. I'm done. Okay. Before I go, I just want to appreciate FlushGate for the opportunity. My sincere, that what you've begun, it's going to go global, and I really appreciate all the attendees. The open source world is there for our own taking, and I know the opportunities for geoscientists, whether it be, it's large, whether it be in groundwater, sustainable development, engineering, everything. So thank you again, Flushgate, for this, and the sky is your limit. Thank you so much.
And we just got a question in from Danny. Would you take a look at the chat box here?
Okay, it does not. Okay, study with. Okay, so, okay. There are different types of concatenation. Which one did you specifically? Which one did you do specifically? It does not seems to be inner or outer join. I understand where the question is going. So let me. What I did now, it's not. I won't say I remember exactly, but I think I actually followed the documentation. Now I know I could concatenate, but I think I tried. I saw a notebook. I saw an example somewhere, and I saw that I could concatenate my words. So I went to the pandas documentation on concatenation. I actually looked at it because it was an issue. I was getting errors, but at the end of the day, I, I won't say I will. Since just drop your email, I will check it and I will send you, because let me not give you a wrong answer to what I'm saying. Yeah, that you say like bouquet. Yeah, you can use bouquet. In fact, I was trying to use this question from Joseph Omojola. I was trying to use Streamlit, and there's this other one, Plotly. But the truth is that I've not really had time because it's involved a little bit of JavaScript, and it means I have to take time off a little bit to on it. It's easy. I think the way they documented is easy, but you could work on it. It's simple. I think last year, we were doing the conference of in Strong conference. There was data visualization, and I saw beautiful presentation. You could use Bokeh, and I saw Streamlit, I saw Dash Plotly. So even this last one, I could do it in Bokeh. I could see the interaction. I could play with it, and it's going to be beautiful. So it's something you could do. It's something possible, and that's the essence of open source. You keep improving. There's no stagnation. It's not like I've written a software, I've kept it. So that's the end, and I read it. So you also can take it, put it on Dash Plotly, or no, on Bouquet, and see the interaction, and it becomes part, and put it on your GitHub repository. Now the like from Danny, the stuff doesn't. Okay, I'll take your name. It doesn't have to follow the descriptive what I call it, descriptive statistics. No, I only work directly with the word. The descriptive statistics is to allow me to see how my wells, the relationship, within that a particular well, not a combinations of all the wells, because the wells are far apart. So it's when I take the descriptive statistics, of each well, and I now relate it to each other, and I'll say, okay, this is the way to go. But I didn't follow that. As I said, I will get back to you. I know it's one of these tabs I've opened is there, and because I could have close to 200 tabs open, I'll check it, and I'll get exactly what kind of concatenation I did. But it was pandas documentation. So if you are stuck, that's why there's documentation for it. There's always a solution. The documentation allows you to see what you could do, and as long it follows the line of science, it is possible. Hello, any other question?
We don't seem to have any more questions right now. Quinley.
Okay. Okay. So should I unshare? Hello? Okay. Okay. Thank you so much. I appreciate the time and the effort. Like I said, yeah, it's an opportunity. I think we could do this again and again, and link up with great minds across board and do something great. I believe the opportunity is there, and for my Nigerian brothers, is there's a lot of work we need to do. What do I mean? It means we need to improve on our data gathering. I think each school, and each department of geoscience must have a repo, a GitHub repo. Let students just put their data. We did a lot of mapping on the as undergraduate, even as masters. We acquired a lot of uh, GPS data moving, but then some of those data are lost. But if we had stored them in a repo, the moment it becomes, I saw the repo from Stanford University for a particular program in their Pagia, I think Pagia, and it does in they have the repo is so large, but it does a particular research, and I was amazed at the data in just a bit of that repo. And I believe, for those who are still undergraduates, let's encourage within your level, create your repo, put your data and your data you gather. We need we need now, data are not secretive. We need those data to solve problems, social development these days. And that was what I would say for those who are still undergraduate, and those who are still this thing. If you have some of those data, find a way to just put it in a repo that people can lay their hands to use. Thank you so much. It's my amazing time and opportunity.
You throw me under the bus here.
Thank you so much.